Hello and good evening. We are from Group 24, and today we are going to be discussing on the CFD analysis of PC case cooling efficiency. So modern high performance PC components such as the CPU and the GPU generate significant heat on an everyday usage. Therefore, inadequate cooling leads to overheating, throttling, or hardware failure. Basically, these components require a proper cooling system, which will cool down all the electronic components, such as the CPU, GPU, and the motherboard. Efficient airflow and thermal management are very crucial during the cooling process. And therefore, CFD allows us to visualize and optimize internal airflow and heat distribution, whereby we can see how the air flows from the inlet right up to the outlet of the PC. There are three objectives to our project. Firstly, to stimulate airflow and heat transfer in a PC case using CFD. Second is to examine the thermal response of key components within a computer case, namely the CPU, GPU, and the motherboard under the influence of varying airflow velocities. Third is to identify the most effective inlet velocity for reducing CPU or GPU temperatures. The next slide contains basically the geometry, the mesh, and also the boundaries. This geometry, as you can see, we have two pictures. The first one is the whole PC component, the whole PC casing, and the second picture is the all of the components. This picture is the initial temperature that we use to record our PC, which is 25 degrees Celsius. And here is our initial velocity, which is 10 meters per second. These two are the properties of the materials being used, mainly copper and steel, which highly contains in the PC components such as CPU and GPU, and comes with our graphical outputs, where, as you can see, there is a slight bit of difference in the difference of velocity, whereby the first picture shows at a higher temperature recorded, whereas the 40 meters per second records the lowest of the temperature. And basically, this is our airflow analysis. This is our animation where how the airflow moves from the from the from the inside, from entering into the PC and exiting out through the exit airflow, or basically the exhaust. Now, in 10 meters per second velocity records the highest temperature, indicating insufficient cooling and potential thermal buildup. On the 20 to 30 meters per second velocity, we can see that there is noticeable temperature drop, showing improved convective heat removal. But as we can see in our 40 meters per second velocity, we can see that further reduction in temperature, but with diminishing returns. Therefore, we suggest that the optimal airflow is to reach around 30 meters per second inlet. The temperature gradient becomes less steep as airflow increases, highlighting the non-linear improvement in cooling performances, as we can see in our previous slides, where how the airflow works. Now, coming into our conclusion, the airflow velocity directly affects cooling efficiency inside the PC case, as we can see just now. Increasing the inlet velocity enhances heat dissipation, especially for high power components like the CPU. However, after 30 meters per second, the gain in cooling reduces, making it less energy efficient to push for higher speeds. Therefore, when we increase too much of the increase too much of the velocity, there is very less efficient cooling is being made. And thus, we can conclude that these findings can help optimize fan configuration for thermal safety and power efficiency in PC design. Without these findings, without the CFD analysis, or how we can see the airflow inside the PC casing, we can actually we can actually optimize the fan configuration for thermal safety and power efficiency in PC design. And these are our references in our project, where we use for our findings and also our references. And yeah, that's about it. Thank you so much. And yeah, this is from group 24. Yeah, thank you so much.